In this video, I'd like to look at some examples of exponential equations that require method 2 to find a solution. Method 2 is pretty flexible, and it can be used to solve equations of either of these forms, where we have variable expressions up in the exponents here, and the equation then could be either two of those with possibly different bases on either side of the equation, or one exponential expression on a side and a number on the other. And so that's the type that we're going to see in this video. And let's get started. Let's take a look. So in the first example here we have 5 raised to the x plus 3 equals 7. To solve that using method 2, I'm going to apply log to both sides. I could use natural log and get a similar result, but let's use log for this first one. And so I get log of 5 to the x plus 3, and then on the other side log of 7. Now the power rule, because inside this argument I have everything raised to the x plus 3 power, it allows me to move the x plus 3 to the front. Since there are two terms, we need to be a little bit careful. I should put parentheses around x plus 3, and we end up with x plus 3 times log of 5, and that's equal to log of 7. So it might seem a little bit weird, but log of 5 and log of 7, those are just numbers. We could find an approximate value for those on a calculator, but at this point it's kind of nice to just keep them in logarithmic notation. So log of 5, it's multiplied by both of the terms inside the parentheses, so we can distribute it next. I get x times log of 5 plus 3 times log of 5 equals log of 7. We can now subtract 3 times log of 5 from both sides. I have to be careful. Logarithms are tricky. They're a little bit complicated. I can't simply combine these two, but I can write them just sort of next to each other. Log of 7 minus 3 times log of 5. And then, since log of 5 is just a number, we can divide, again, both sides by log of 5. And then we get a final answer to the equation of x equals log of 7 minus 3 times log of 5 divided by, all of that, divided by log of 5. So this works as an answer. It's called the exact solution because it doesn't involve any rounding. We could use a calculator to find an approximate solution, and we need to be a little bit careful. We want to make sure both of these terms get into the numerator, so you might want to use parentheses if you type that all at once into a calculator. If you do, you should see a value negative 1.7909. And if we took that number and plugged it back into the original equation, we should get approximately 7, right? Because of the rounding, we might not get exactly 7, but if we add 3 to this and then raise 5 to that power, we should get approximately 7 as the result. So the approximate solution is kind of nice because it can help us check our work, and we can use it to find where the value would be on a number line and sort of compare it to other numbers. But the exact solution is, in a way, sort of nicer because it doesn't involve any rounding. It's as precise as we'd want to make it. For this second example, because the exponential expression is base e, it makes sense to use natural log to try to find our answer. I encourage you to pause the video for a moment and try to find the solution on your own. The process is very similar to what we did in the first example. In a moment I'll show the answer, but I encourage you to pause the video and try to figure it out on your own first. So for this example, let's apply natural log to both sides. And then, as with the first example, the power rule allows us to bring the 2x to the front and get the variable out of the exponent. Now, using natural log makes a lot of sense here because the exponential expression is base e, and it turns out the natural log of e is just equal to 1, because this is basically asking the question, e raised to what power equals e? But of course e to the first power equals e. So the natural log of e just equals 1. This just equals 1. And multiplying that with 2x is not going to change the 2x. So we end up with a simpler equation, just 2x equals the natural log of 5.4. And so to finish the problem and solve for x, we can divide both sides by 2. And that gives us x equals the natural log of 5.4 divided by 2. That would be the exact answer. To find an approximate answer, we could type that into a calculator. We end up with 0.8432. And with the approximate answer, we could use that to check our work, plug that back into the original equation, make sure that it makes sense. We won't get exactly 5.4 because of the rounding involved here, but we should get pretty close. I hope you enjoyed the video. Thanks for watching.